This is going to be the first of 3 videos that start to explain how to use the tools that we're going to need for the next assignment. So they're going to be the grippers, which allow us to grip the blocks, a stack component, which you may or may not use, and the pick and place component. So all of these components are part of HAL, and they're located on the HAL tab toward the end here. All of these 3. So the parallel gripper, the pick and place, and the stack. So I'm going to cover the parallel gripper first, which is essentially a module or a component to make a tool at the end of the robot. So you'll notice here in Rhino I actually have the geometry of the tool. So this is the part that stays on the robot. So this will be the gripping body. What's on the existing robot right now, well, we had an LED connector, but these are permanently attached with this as a tool changing part that comes on and off. So if we take the LED off, we remove this base, we replace it with another base which has the gripper on it, and so that'll give us this. These are static components, they do not move. The gripper sliders in here actually move, but it's the fingers that will move. So, and I say this because we're about to cover the other component. The other thing to look at and remember as we're making tools within HAL is the tools happen in the negative Z direction. So the way I have this set up right now, the tool will be backwards on the robot. So you can imagine the robot kind of comes down and grabs the tool at the origin, and anything in the negative Z is what gets attached to the end of that tool. So I really need to take all of this geometry and rotate it. So I'm going to use a rotate 3D command, start the axis at the center, and just hold down shift and basically lock this thing to a 180 degree movement to just flip it upside down at the origin. So it should be right at the origin still, and we should have all of our parts. From here I can begin to work on creating the gripper component. Now I'm not going to go over these in order, I'm just going to go through them as they're needed, and I'll try to explain the other ones as we go along. So looking at our tool, we essentially need the geometry that's going to fit into the gripper so it can simulate the gripper at the end of the robot. So in this case, looking here, I see I need a body, and that's why I was saying the static components, the parts that don't move, and a left and right finger. I don't know why they ask for these because they don't actually move, and there's really nothing that differentiates the left from the right. If anybody can figure it out, that would be great. I'd love to learn it. But for now, I'm going to do is use a geometry component. Say set multiple geometries. In this case, I'm going to select all of the static parts and hit enter. Alright, with that done, I'm going to repeat it for each finger. So I'm just going to create a geometry, duplicate it. In this case, I'm going to do set one geometry, one for one finger, set one geometry, one for the other finger, and connect these up. Right. If I want to be really diligent, I'll come back in here and name these so I can identify them later. If I really wanted to be more diligent, I would internalize this data so that the geometry would stay with it and I wouldn't need to attach it with a Rhino model. But I'm not going to do that. So for now, I'm going to hide this geometry, and I'll explain why in a second. I guess it didn't matter, but I'm going to do it anyway. So now that I have this, I need the mass. Mass is just a numeric value. In this case, I think it's something around 4.5 kilograms. I can provide an exact number at some point, but that's all we really need. The stroke is the distance that the fingers will move. So these have a stroke of a certain distance that they'll move and out and back in. In our case, I'm pretty sure it's around 25. But again, I don't think these actually matter because the fingers don't move in any simulation or any other part. And if they do, I don't know how to do it yet. Right? But these are required values. The grip ratio I'm going to come back to, and those are going to come back to being defined with these. These 3 components are important. It's a fixation plane. It is the plane that attaches to the robot. And the reason why it's not always 0, you can imagine if you had a tool that came out at a right angle or did something else, it would actually fix to the robot at a different part. But in our case, it is at 0, 0, 0. I could just put in an XY plane. This is one way of doing it. And then I could copy this plane for the other planes. Right. These are essentially 2 planes for the gripper. One is the end or the tip of the grippers. That's what's called the S plane, or the shallowest gripping plane. And the D plane, or the depth. In this case, we're using sort of the end of these rubber parts that we put on the end of it as the shallowest gripping plane. And essentially what that means is we can control through the grip ratio where the gripper will go and actually grab the component or the block. Everything that we talk about from here on out will be talked about in planes in terms of pick and stacking. What do they call it? Yeah, pick and placing. It's in terms of the top of the object, so the top plane. We will always be defining planes in the top of the geometry, and it will match plane to plane. So if I have a 50% gripping ratio, which will tell it to match the plane at the center of this to the top of that other plane, so that'll dictate how much of the block it actually grabs. And so to set these planes, we could go to the robot and do what's called a TCP, meaning I take this tool and I do a calculation through jogging to figure out how far away the end of that tool is from there. And then that would just be a matter of using a Z vector with a numeric value of whatever that number came out to be, and actually making it a negative value. Right, so I'd feed it through, and that would define the tip or whatever the end of that is. That's one option. Another option which I like to do is to create a point. So if I came in here and started to draw a line, I'm going to have to snap to a vertex because this is mesh geometry at this point because I've meshed it out. All right, so let's try it again. Oh, there it goes. All right. So I'm drawing it diagonally, and then I'm going to make a point at the midpoint of that line. That'll give me the center. So if all my geometry is accurate, this will work. And I know for a fact that all of my geometry is accurate. So I can do this. I'm going to explain the drawback in a second after I get it set up. One drawback could be that you're not actually snapping to the right geometry, which is what's happening here. Another drawback could be that since it's going to be dependent on points or actual geometry, if that point or that geometry moves and you don't move it, or you don't know it, or you move this geometry and you don't move the point with it, you won't know. It'll mess everything up without you knowing. So sometimes the numeric value is the best, because once you have that numeric value, it doesn't really change. But in this case, I'm going to use my points anyway, just for demonstration purposes. I'm going to use 3 points, because I'm actually going to create one more in here at the origin. All right, so I'm going to set my origin point, which is here. All right, so I'm essentially setting points of where these planes exist. I'm going to set my shallow plane, which is there, the end of it. And I'm going to set my depth plane, set 1 point, which is there. All right, and now I can set up a slider on the grip ratio and grip between. It wants to be an integer, not a whole. So let's just put a 0.5 in there. Computer's acting really funny. There we go. All right, and what this does is it will adjust the plane, the gripping plane, as a percentage in between these two planes. It's interesting, right? So we don't really see it working now, but you can imagine at 100%, it will grab, they'll shift that plane up to here, at 50% at the middle, and at 0 at the end of the grippers. I could have that backwards, but since I have no visual indication of it, I won't really know. I do need to have a name, so I'm going to put a panel with a name. If I don't have a name, the component doesn't work. All right, so now that I have a name, it turns orange, returns the right color, those turned orange. All right, so what we're seeing, let me see if I can hide the actual geometry. We're seeing a representation of this geometry through the gripper here. This, if I turn this off, please be right, yes, it will turn that tool on and off. So I actually have 3 different representations of the geometry. The original geometry, which I hid in Rhino, the geometry which I attached to the geometry buckets here, which are now hidden, and then the geometry through this component that shows all of it. All right, and you can see here, HAL gives you this nice indication that the robot is supposed to be on this side. All right, so in order to end this, I'm just going to show it quickly on the end of the robot, and in order to do that, we need to quickly create a toolpath. So I'm just going to come in here quick, toolpath creator, hook it up. I need a couple components to satisfy it. One of them being a target, so I'm just going to create a point in space. Hopefully it's far enough away from the robot. We're about to find out. Point bucket. Set 1 point. Targets. So I'm not giving it everything it needs. It needs a speed in order to actually create it. So I'll do a speed preset. Speeds. Of course, everything needs a name. I think all I need is the TCP velocity. Should be it. Nope. Let's come back over here. Oh, I didn't put the tool in yet. There we go. Come on. I'll just turn this on. Oh, yeah, I'm way off. Let me just in the top view put that point somewhere reasonable. There we go. Hide this robot. Show this one. There we go. All right, so what you should see through all of this is a correct placement of the tool at the end of the robot with the gripper information. And if I change this grip ratio, we should see, there we go. See how the robot is now moving in space. Alright, so it's changing where it's going to grip that plane in relationship to that grip ratio. So that's essentially how you make a tool. In this case, it's a gripper, but in order to create any other tool, it's pretty much the same. I'll quickly pull up. I'm not going to go through it, but I'll just quickly pull up what we were using before, one of these. All right, so it's eventually the same thing, static body, different types of the geometry, a mass, whether it's on the robot or not, a TCP value, which is what we did here with the fixed plane. So similar information to create a tool. We made that for you last time, but now you should be able to figure out how to make your own. So I'm going to stop this now, and I will try to make 2 other videos on the pick and place, which is pretty extensive, and on the stack material.